Hello, hello, hello. How's everybody doing? Oh, come on, give me the energy. Yes, yes. Thank you. Thank you all for being here. I really appreciate it. How's Ignite been? We're like day 4 in. I've still got plenty of energy. It's been a really invigorating week for me. I love the opportunity to come and speak with customers and learn. I'm a product manager, so obviously I want to learn what's working, learn what opportunities we have to build, and it's been really exciting and invigorating. And I was just thinking, before I ran out on stage and tried not to trip, I thought to myself, you know, it's great that I get to stand here on stage, but I'm honestly very thankful that I get to speak in front of you all, and I get to stand on the shoulder of giants. So many of the folks on my team who are actually responsible for much of what I'm about to show couldn't actually make it. Some of them are in Germany, other parts of the world. So hopefully I can do their work justice and give you the best of my energy, but I'm really excited to get in this content. So hello and welcome. Don't worry, we're going to have a good time. Today we're going to be covering how to manage, observe, and troubleshoot Modernize Kubernetes application using several open source projects. So key there being open source projects. You can pick all of these projects up and run them on any cloud or run them on-prem or run them on your laptop. So what you're about to see here, it's great that I get to present it being at Microsoft and I get to work on this stuff, but you can run it on any Kubernetes cluster anywhere to troubleshoot any of your applications. So let's go ahead and get into it. See if my clicker works. It's always the magic first click. Not going? Clicker? I will use the old school way of... Is that progressing? Do you see me on the screen? No. Okay. Well, that's a good start for me. Let me go ahead. I can't get this to progress. The slide deck. The slide deck will not progress. So please stay tuned. Thank you. This is Cody. Cody's wonderful. Please give him a round of applause. Cody's going to get us all back to normal. But while Cody does that, I'm actually a stand-up comedian by leisure. I'm kidding. Okay, all good? All good. All good. Thank you very much. Okay, I think we've woken it up. Yes, we have. Okay, so about myself. My name is Lachlan Evenson. And judging by my accent, or if you've heard this joke before, I am a local from San Francisco. So I just walked 2 miles from my house this morning down to this event. It's my 3rd event in 4 weeks, so this was the only one I got to walk to. So thanks if you're joining us from around the world or online. Appreciate you all being here. I've been at Microsoft about 7 going on 8 years. It's been a wonderful 8 years. I actually came to Microsoft to build AKS. I was part of an acquisition of a company called Deis, and we were commissioned to build the Azure Kubernetes Service, which maybe you've heard of or had the opportunity to use. I'm a principal product manager on the Azure Cloud Native Ecosystem team, where I take care of services like AKS, Azure Kubernetes Service, Azure Container Registry, Azure Red Hat OpenShift, and many more. And I get to work with an awesome team from around the world. A few fun facts, because I always like to know who's talking to me. Let me know a little bit more about them. I've written 2 books on Kubernetes, published through O'Reilly. One is Kubernetes Up and Running, and the other one is Kubernetes Best Practices. If you're new to Kubernetes, feel free to go check those out. And I'm also the board member for Microsoft for the Cloud Native Compute Foundation, which is the open source foundation that has projects like Kubernetes, Prometheus, and many others. Interests and hobbies about me: I love language, I love culture, and I love travel. My favorite country I've ever traveled to is Japan. I love Japanese food. My favorite Japanese food is 𝗦𝗽𝗀𝗀𝗃. Look it up. It's really cool and really ornate, and I love the flavor. Languages, I speak 3. I want to learn 7 while I'm on this earth. So you can come and talk to me about the 3 that I currently speak, and maybe suggest the other 4 that I might want to learn. I'm thinking about Arabic, maybe Hebrew, or some other ones. I love language, love communication. All right, so let's take a look at the open source ecosystem. One of the really cool things about my job is I get to work on open source day in, day out. And that's not because I want to. Of course, I'd love to, but our customers are actually requiring us to run open source on our cloud and across our platforms and services. So we don't have the luxury of open source being an afterthought. Customers are asking us for it to be part of our strategy. And open source is at the foundation of how modern cloud systems are built. And we are no exception. So across the CNCF ecosystem, or the Cloud Native Compute Foundation ecosystem, and well beyond it, Microsoft engineers contribute upstream every day. But it's not just for our own sake. We actually do it because we utilize many of these projects internal. And actually, you can see on the top of this diagram here, You see platforms like GitHub, Microsoft 365, which is the home of platforms like Office Online, LinkedIn, Xbox, and many other platforms and services are actually built on top of services like Azure Kubernetes Service and utilize open source platforms like Kubernetes under the hood. So the really cool thing is being able to operate at that scale, and actually there was a session by the M365 folks earlier today about how they're operating at scale on top of AKS. It's taught us how to run modern workloads that are cloud native on cloud native platforms like Kubernetes. And it's allowed us also to give back through contribution of some other projects where we see gaps in the ecosystem. So if you look in that bottom layer, you can see several different projects that the Microsoft team has worked on and collaborated on with the ecosystem. And there's some of Notary that we're going to go over this afternoon. One really cool thing, and my goal in my team was actually to make us the largest cloud provider contributor to the CNCF over the last year. So I've been here 7 years, and I've worked on that goal tirelessly, not individually, but with a large team, to become the largest cloud provider contributor to the CNCF. So if you're using any of these projects, you rest assured we're building upon them, and I'm going to show you how we're integrating them into products as well. So, but let's take a look. You came here to learn about how you can manage, troubleshoot, and resolve issues quickly using open source platforms and tools. We've actually categorized some different areas that we want to take a look at when you're trying to introspect how your applications are running. So modernized applications running on Kubernetes. Here are 3 different areas from left to right. First, we have understanding your environment. So what does that mean? It means understanding and having a clear picture of what's running, how it's configured, and how everything connects. Remember that piece, because I think that's very hard. Without that baseline, you're flying blind. Second, runtime observability. Metrics and logs aren't enough anymore. You need real-time insight into how workloads actually behave so that you can troubleshoot and keep things healthy. And third, detect and react. I think react, sometimes we can even get to proactive engagements these days with AI models as well. But modern systems are changing consistently. I think the saying is, change is the only constant. The quicker you spot meaningful changes and trigger the right responses, the more resilient your platform becomes. So together with these 3 areas, understanding, observing, and reacting, we're going to define what some tools are that you can use in the Kubernetes ecosystem and how to use them in practice. So I'm going to introduce several tools here. So I think the really cool thing with these tools is we're not adding proprietary layers to the stack here. As I mentioned, these are all open source. You can pick them up today. They're available and in open source communities on GitHub. But the great thing about open source is it gives you clear, composable building blocks to manage your cloud-native applications. And the best part is you don't have to reinvent anything. So you can use these projects together or individually to make your own platform and make it your own. So the projects we have here up on the screen, Headlamp, Inspektor Gadget, and Drasi, slot straight into any modern ops stack that you may already have and tackle the main core problem that ops teams are facing is how do I make sure that my apps are running how they need to run. So let's take a look at how these applications or these projects map to cloud-native modernization. First, you see your cluster. So we want to take a look and observe our cluster and what's running. Headlamp gives you a clean visual representation of what's running, where, and how. So no more YAML or CLI digging needed. So I don't know, I say that in one sentence. I don't know how many of you are stuck in configuring YAML or taking a look at CLIs, but when you're dealing with the complexity of cloud-native applications on top of platforms like Kubernetes, you want a single pane of glass to give you clear and observation of how your apps are configured. Next, if we want to see what's happening, as runtime observation, there's Inspektor Gadget, which is kind of a cute name. It was one of my favorite shows as a child. I think it was spelled slightly differently. Go Gadget Arms, if anybody remembers. But it shows low-level, real-time insights and how you can spot issues, bottlenecks, as they happen with minimal overhead. So I'm going to show you how you install these gadgets into your cluster and get real-time insights with very little overhead. And finally, reacting instantly. That's where Drasi comes in. It listens for changes and triggers actions automatically, updates dashboards or alerts to kick off workflows to remediate issues. And together, these tools simplify, speed up feedback, and make Kubernetes management cloud agnostic. So sound good? You ready to go jump into these things? We're going to start with Headlamp first of all. I'm going to give you more of an understanding of what Headlamp is and the value it provides. So understanding what's running in your environment can be challenging. Who here is running AKS or on Kubernetes? Is there any folks? We've got a few folks. Okay, do you think that's challenging? Yeah, getting inside? Okay, so this is where Headlamp is here to help. Headlamp gives you a rich, modern UI with a clean interface that makes clusters and workloads easy to explore without digging through YAML or memorizing commands. So even though I've worked in Kubernetes 11 years, I was a much younger looking version of myself when I started with Kubernetes, I cannot memorize all the commands to effectively run and troubleshoot applications on Kubernetes. So a tool like this is even great for somebody who's been doing this for a long time. It's open source and it's officially part of the Kubernetes SIG UI. So SIG is a special interest group in the Kubernetes ecosystem. So this isn't something Microsoft owns. It's something that Microsoft actually started working on based on customer feedback and we gave to the CNCF. So it's community driven. It works across multi-cloud and multi-cluster environments. I think it's really cool. We're going to show you how that works, but you can select multiple clusters across multiple cloud providers and see your workloads across those environments. So you're not locked into one vendor. You can see across all cloud platforms and providers that you may have. And you can run it as a web app or in cluster. You can run it as a desktop app locally, so it'll install on any platform. I think even the demos I'm going to show are built on Linux desktop. So it's there and gives you great flexibility. And it's extensible. The extensibility piece is actually my favorite piece of it, and we're going to show how you can run an AI assistant agentic workflow through there, but there's a deep plug-in system to add features. So even if you're using Headlamp, you can make it your own very simply using the extensibility that that platform provides. So it lowers the complexity without hiding Kubernetes to give you clarity and control. That's Headlamp. It's cute. I like that little head-on train. So let's take a look. If that wasn't clear enough, let's take a look at why you might want to look at Headlamp or what it can do for you. It simplifies Kubernetes, so instead of memorizing commands or YAML, you get a clear visual representation of clusters and workloads. There's also a feature called projects for those who say it like me, where you can actually group resources. So one of the complicated things about resources in Kubernetes is there's no definition of an application that's standardized. But with projects, you can actually create a consistent view of how your applications come together. So second, it speeds up onboarding. So what we find is folks in the community who are new to Kubernetes really want to get the power of Kubernetes under the hood without understanding or learning all the intricacies and complications of Kubernetes. So new developers can start faster because complexity is reduced and no more spending hours specifically on configs and permissions that you may not have had exposure to. And third, it brings consistency. I actually heard earlier from the M365 team that they use Headlamp specifically to have a single pane of glass. So you have, instead of juggling multiple tools and dashboards, Headlamp gives you a unified view that means less context switching and smoother workflows. So bottom line is Headlamp lowers the barrier without hiding Kubernetes, and it makes the experience approachable and efficient. So I think that's really the power of Headlamp under the hood, is that we can bring that complexity of Kubernetes, but also make it very approachable. I've heard it said that, it's the app you want in the App Store that actually gives you access to your Kubernetes cluster. I think of it like that. I'm going to take a look at two pieces before I give you a live demo here. Kubernetes apps, as I mentioned, they're not just one resource. So we actually have a concept called projects, which you can actually, using Kubernetes primitives such as labels, you can actually grab a set of resources running in your Kubernetes cluster and reference them under a project. So you may have pods, services, deployments, often spread across different namespaces. Without grouping, managing them feels like solving a puzzle. So Headlamp fixes that by giving you an application-centric view instead of digging around for all the resources that compose your application. So it's a a shift from resource focus, which Kubernetes is, to application focus, making Kubernetes management simpler and more developer friendly. And as I mentioned before, the extensibility is really cool, and what we're going to show here quite soon is an AI assistant running, so actually using an AI assistant to be able to interact with your Kubernetes cluster. So, you know, instead of memorizing commands like Kubernetes, kubectl, get pods, dash, whatever, you can ask using natural language like, show me the pods and staging, show me why my deployment is failing. And it's not just about fetching data, it's helping you troubleshoot, explaining errors, and giving you inline feedback on how you might go about troubleshooting an issue, lowering the time to resolution. So Kubernetes with an AI assistant, it becomes conversational, making it faster and easier for everyone. Okay, so demo. I was going to do a live demo, but I didn't feel as brave as I felt earlier, so I thought I would actually channel somebody who helped me with this demo. His name is 𝗦𝗲𝘀𝗀𝗃, and he's based in Berlin. He works on the Headlamp project, so you're going to hear from 𝗦𝗦𝘀𝗀𝗃, and he's going to walk you through a Headlamp demo. Okay. I'll be ad-libbing on top of this.
Managing multiple clusters in Headlamp starts with a simple action. You select the cluster you want to work with, and then click View Cluster. This approach removes the need for complex commands and gives you a clear visual way to start exploring your Kubernetes environment. From the overview page, you could quickly navigate to workloads and notice the cluster column displayed in the UI. This column is especially helpful when you're managing resources across multiple clusters because it provides that instant visibility into where each workload resides. Now let's explore one of Headlamp's most powerful features, the map view. This view gives you a visual representation of relationships between resources. You can see how services, deployments, and pods connect, and at the same time, identify which clusters those resources belong to. It's not just about visualization, it's about clarity. Here, we're doing a drill down into some of our resources from the map view. And while in the drill down, we can also see what cluster the resource belongs to. You can also access custom resources, view your constraints, and even review security configurations directly from this interface, all the while being able to filter by your cluster as needed. With the basics covered, let's move on to something that truly sets Headlamp apart, the AI assistant. To enable it, navigate to the plugin catalog, select the AI assistant, and connect your preferred provider using LLM endpoints and API keys. This flexibility means that you can bring your own model and integrate it seamlessly into your own workflow. Here, you can see us grabbing our API keys and LLM endpoints from the source so that we can configure the AI assistant. Now that we've configured the AI assistant, we can access the chat box from the AI assistant icon on the top right of the screen at any time. Here, we're asking the AI assistant how to create a config map. The assistant responds with an option to edit the config map directly from the built-in editor, but in a typical environment, we'd want these actions to be a part of our GitOps workflow, which we'll show next. For now, we can edit the config map via the editor, and then once we're done, we can delete that config map. And now, moving on to a GitOps workflow, we can see how the AI assistant helps in this scenario. In most Kubernetes workflows, GitOps plays a critical role. Headlamp embraces this by integrating with the GitHub and Flux MCP. This integration allows the AI assistant to understand GitOps principles and guide you through the actions that align with best practices. For instance, when the Flux plugin is installed, you can click Sync to push changes back to your source repository, and this keeps your cluster state consistent with your GitOps workflows. After syncing, you can now navigate to deployments to see your updates in action. And then from there, we can also go back to our chat box if we want to make any edits or changes, all while in the GitOps workflow. So for instance here, if you needed to scale up, you can make those changes and then apply it to our GitOps workflow. And if you want a broader view, you can return to the map view to see your Flux customization in action. This visual feedback helps you to validate that your changes are not only applied, but also structured correctly across your clusters. Headlamp makes multi-cluster management simple, gives you clear visibility with the map view, and streamlines workflows with AI and GitOps integration, bringing speed and confidence to Kubernetes operations.
Excellent, thank you. And my apologies, I misspoke. It was actually Will that did that demo, so thanks be to Will. One of the things I love is, working with Kubernetes for many, many years, I always thought maybe a UI was a little bit below me, and I was a CLI guy. But actually, all my workflows have changed to this method of interacting with Kubernetes using AI assistance, because it requires me to learn less of the commands that I need, and I can also use natural language to interact with the cluster. So it's great that you're able to model that type of workflow with that kind of power and confidence with an LLM in the background. So I think it's a great application of the AI agent space. Okay, so moving on. We actually have an integration. So one of the things we like to do with all of our products is start them in open source and upstream specifically. So Headlamp is upstream. And then actually build product integrations downstream. So this is exactly what we did with AKS Desktop. It is built upon Headlamp, but as a productization of the Headlamp project. So we chose this foundation, as I said, to give a real commitment to open source by starting in the open, contributing upstream, and then bringing that work to customers. For teams, it means an application-centric experience from the start. You deploy and manage across local, test, and Azure environments with a consistent interface. AKS Desktop integrates supported AKS features and brings guided setup. So best practices are easy to follow with no extra homework. You get sensible defaults, clear guide rails, and workflows that match how AKS is run in production. Because it's built from the Headlamp desktop app, you benefit from the same familiar patterns and community users, from improvements to the flow and how the project evolves. So that's a great way for you to be able to use AKS Desktop and benefit from many of the features you just saw in Headlamp under the hood. And as we saw in the demo, it's very flexible and extensible. So the Flux, if you're using GitOps, Flux is a great tool to use for GitOps workflows, but it has a plugin system, and as you can see there on the right, you can see the plugin catalog. So it's very easy to add new functionality, and in fact, that AI assistant functionality was delivered, if you watch closely in that demo, through the plugin system. But it allows you to go search the plugin catalog and install very, very quickly. And also, if you want to make this application your own and you have folks that understand how to write a UI, you can build and publish your own plugins for Headlamp. Okay, I want to give one more Headlamp example here, but looking at it, how it can combine with Inspektor Gadget to give you detailed resolution. So we're going to take a look at another demo that's quite short, but this demo specifically, we're going to take a look at how we can use the Inspektor Gadget plugin to actually troubleshoot a real-time issue. So here we go.
In this demo, I will take you through how you can use Headlamp to get deeper real-time insight from your Kubernetes cluster. Here we are trying to deploy MySQL as a Kubernetes daemon set. We can see one of the pod is stuck on container creation. Now, one of the reasons for slow startup time is I/O saturation on a node. In order to confirm this theory, we can use Inspektor Gadget Headlamp plugin. We see here that we are already running a gadget profiling the block I/O. This block I/O gadget will give us histogram for each of the node. From these histograms, we can clearly see that the node at the bottom where the pod creation is slow is actually experiencing high I/O operations. This demo shows how we can use Headlamp together with Inspektor Gadget to get real-time insights to quickly troubleshoot our issue.
Thank you, 𝗏𝗀𝗻. That was absolutely fantastic. It made it look almost too easy. I don't know how many times I've gone into container creating and not being able to understand exactly why that workload isn't starting, that MySQL server, but being able to have real-time insights driven by Inspektor Gadget under the hood is really a great pairing of those two projects to see the power. So that takes me to what is Inspektor Gadget. So we did see through that example a block I/O issue where Headlamp was powered by Inspektor Gadget under the hood. So we're going to take a look at how you can utilize Inspektor Gadget to have real insights and deep troubleshooting for your Kubernetes workloads. So again, Inspektor Gadget is another open source project that our teams worked on for troubleshooting, monitoring, and security. It can be used on Kubernetes clusters, but it can also be used on Linux hosts directly. The key feature that makes Inspektor Gadget suitable for debugging Kubernetes issues is that it's Kubernetes aware. Many troubleshooting tools are not Kubernetes aware, so sometimes you miss that context. So with every Inspektor Gadget every single flow is a kernel level event that's enriched with Kubernetes metadata, and you're able to filter specific Kubernetes resources, namespaces, pods, and nodes, and etc., which makes it very easy to start at Kubernetes and get to the root cause of complex issues because we've taken care of all the heavy lifting, connecting all the Kubernetes metadata to enrich the workflows to get to your troubleshooting. Inspektor Gadget extensibility is through a set of tools that are called gadgets. So you saw in the Headlamp view that we just showed, it was gadgets, and gadgets was powered by an Inspektor Gadget gadget. We're going to go into what those gadgets are. But each of those gadgets has specialized functionality and a set of use cases. And you can see up there underneath Inspektor Gadget in the black with a little b, it's actually powered by a platform inside Linux called eBPF, which allows you to attach programs into the kernel space and not have them run in user space to get detailed monitoring and troubleshooting feedback from what's happening in the Linux kernel. So those gadgets can be used in, we've identified three main different areas. One, troubleshooting for real-time debugging. Two, monitoring for generating metrics and continuous monitoring and alerting. And three, for identifying malicious activity and security. For instance, Microsoft Defender for Cloud is actually, for containers specifically, is powered by Inspektor Gadget under the hood. So this is another case of where we're using this technology to power products internally as well as for our customers. Okay, we're going to go over just a few different gadgets that we have out there, so based on use case. So there are some core observability powered by these gadgets. We have a library of gadgets that you can pick up off the shelf, so we pre-built them, and they're in a library where you can search and install them. We have many different gadgets around resource utilization, and for example, in the block I/O demo you saw before, that was under the resource utilization gadget. So another gadget we have is the top process. So if you ever use top on Linux, it shows you the top resource utilizing processes on your Linux box. We have a TCP dump gadget as well, which we can capture network traffic in Kubernetes environments without having to log into the nodes directly. If you've ever tried to troubleshoot traffic flows on Kubernetes, it can be quite cumbersome, but this tool makes it really easy to do it across the surface area of your Kubernetes applications. And you can resolve issues like DNS issues, because we all know it's always DNS, packets being dropped, services not being reachable, and the data that's actually produced is using PCAP compatible filters under the hood. So for those networking folks who like to geek out on Wireshark, you can take these packet captures and feed them straight into Wireshark. And the trace open gadget finally shows which files are open on the file system. Remember, Linux and Unix platforms, everything's a file. So you can have a look at what's open and what's utilizing the files and what you wish to remain secure. So when you're looking at things like malware running on the system and cryptojacking, open files is a great way for you to also pinpoint malicious activity that's happening in binaries and directories. So this is just a small sample of some of the gadgets that you get out of the box for free in Inspektor Gadget. So you can even write your own if you're familiar with eBPF, but we make it really simple to grab them off the shelf. So now you know a little bit more about what Inspektor Gadget does. Let's take a look about how you might use it. If you want to do on-demand troubleshooting from the terminal, we have a CLI that you can do that. If you want to build continuous monitoring and alerting using OpenTelemetry, Prometheus, and Grafana, you can do that too. And finally, if you want to use generative AI, like you've seen, we have an MCP server that we shipped with our AKS MCP server, which does automatic tool and gadget selection to make it super easy to introspect and troubleshoot your Kubernetes workloads. So we're going to go into a demo and actually take a look at that. This next demo, 𝗲𝗀𝗀's actually going to take you through a running application on Kubernetes that has an issue, and we're going to use Gen AI inside VS Code to actually troubleshoot that issue and generate an RCA. So generating RCAs has never been easier. So I'll pass it over to 𝗲𝗀𝗀. Take us through this demo.
In this demo, I will take you through how we can use Inspektor Gadget for troubleshooting and to perform root cause analysis. Here we have a sample application with different product. I can add a product to the cart and then press the checkout button to submit an order. We have here a special product called Inspektor Gadget, and the special thing about this product is I have injected a DNS error into the order submission flow. So if I now press the checkout button, we should get an error. And the goal of this demo is to give this information to the agent and see if it is able to perform root cause analysis. I'll start by giving my agent a prompt. Hi, I'm having issues by checking out a product. The application is running on the AKS cluster in the current context. Can you please help me troubleshoot it? I hope it isn't DNS again. Also, please feel free to perform everything. Example, getting pods, starting traces before asking me to reproduce so we can perform RCA.
Does everybody talk to their LLM that politely? I hope it's not LLM. I hope it's not DNS again. I hope it's not. But it's really interesting just with that prompt here. We can actually see it start to introspect what's happening.
So it starts by gathering some information about the cluster.
So what it's actually going to use under the hood is MCP to be able to introspect a running AKS cluster and start the troubleshooting process in order to resolve the issue or pinpoint and create the RSA. So we see that working right now. What it's doing is going out to the Kubernetes cluster. You can actually see...
I have auto-approved some of the
Thanks,
MCP
𝗲𝗀𝗀.
tool calls to speed up things. So now it understands that it has these different microservices. Now in order to observe DNS, it needs to check if Inspektor Gadget is deployed. I approve the request. So it'll start these different gadgets, one for DNS, one for TCP.
I think this is really cool. If you haven't actually used an MCP server in VS Code, I encourage you. But you can see those little commands. They're actually tools configured in the AKS MCP server to do specific actions on the cluster, like install the DNS gadget for Inspektor Gadget or the TCP. We talked about TCP dump gadget. That's what it's doing right now. So it's installing those things in order to be able to troubleshoot the issue. So with that one simple prompt at the start, it's actually taken these actions, and it's just asking for feedback as to whether we allow these actions. Remember, in these agent modes, we always ask for approval.
So now it has performed all the steps to monitor, and then it will ask me to reproduce the issue so we can catch any issues. Now I will submit the order a couple of times again, and then write done.
So we just actually live reran the issue.
It should capture the traces for both the gadgets. So now it claims that it has found
if you look
the issues.
closely,
So order
you see
service
the
is
issue.
indeed trying to connect to myexternalendpoint.com, and it is also able to find the DNS and the TCP trace, and then also now it understands and it is going to clean both the gadget so that we don't have any resources. So now it has completed the whole root cause analysis. It also even have the latency numbers and everything in there in the final report, and it says that, so yes, it is DNS again.
Yeah, so, you know, all's well that ends well, but I think it's fantastic that you can actually query and use and prompt to run detailed troubleshooting processes. So that what you see there is a mix of VS Code with the AKS MCP server installed, and that we're using that to power that prompt to do the troubleshooting on the back end and generate that RCA. So I cannot speak to how many hours I've spent banging my head against the wall trying to troubleshoot issues like that. With a simple prompt to introspect that application and deploy those gadgets under the hood, it makes it look terribly simple to get to the final result. So I think that's incredibly powerful. And, you know, I haven't been this excited about troubleshooting applications in years, but when I see that we were at this point, it's really quite exciting to see the future of this technology, and I'm excited to see what everybody builds. I think one of the great things with open source is you all can come up with great ideas and build on top of this. So hopefully that inspires you or gets you curious about how you can use Gen AI in your troubleshooting of cloud-native applications. Okay, finally, we're on the home stretch here. We're going to go and take a look at a project called Drasi. So what Drasi aims to do is, you know, the cloud-native applications are constantly moving. So things are changing all the time. There's inputs, they're reacting to change. So the data doesn't stay still as much as the application doesn't stay still. So new updates get published to databases, APIs change, and you know, even things like AI are interacting with your application. So it's very tricky to actually react to different situations on the ground as your application and its environment is changing. So we created this project called Drasi to kind of come up with this idea of change-driven solutions. So as your application, the environment it's running in, and the data is changing, how can we actually create a change-driven platform to drive change-driven solutions? So I think this is a really interesting take on a problem space, and I'm going to go through what Drasi does for you. So any system that needs to respond in real time to important critical changes is a change-driven system. We're introducing this terminology. The need for them is everywhere, and you're probably using them today. For example, large IT companies constantly emitting health signals and telemetry that you want to know as soon as possible as a specific event or anomalies occur so that you can mitigate the issue. In a retail scenario, you may need to detect when inventory falls under a certain level from a stream of inventory information that you can trigger a reorder. And just as important as detecting a change is detecting an absence of a change. So in an IoT use case, if a freezer were to go above a certain temperature and stay there for a certain amount of time, that is, it doesn't change back to the expected temperature for 10 minutes, you may want to dispatch an operator to check on it. So these are some common scenarios that we saw a gap in the ecosystem. There are ways to do this, of course, today. So most systems today treat every event as equal, which means they collect a flood of information with data that's expensive for you to process, store, and analyze. But the truth is not all events matter. I'm probably not telling you anything you don't know there. So to separate what's relevant, teams spend a lot of time and effort filtering and tracking logic. If you take polling, for example, consistently checking databases for changes that may not even exist. It burns compute and takes load for no additional reason. Or change log processing, as we see there in the middle, where you have to inspect every single event, decide if the event is meaningful, and then run extra logic and add context. Multiply that across all your different data sources, and it becomes quickly unmanageable and unscalable. And then there's stream processing, which I think most people do in the cloud-native ecosystem, which often means pushing everything into a data lake where you analyze it all, throw most of it away, which adds complexity and delay. All of this makes it really hard to build change-driven systems and the ones that actually focus on things that changed and react at the moment it happens, and not all the other stuff that's in amongst all that. So Drasi introduces some different points here of context. So if you can only measure the changes you care about, Drasi can come in and help you with this. Drasi is an open source project as well in the CNCF. It's designed to build and make maintaining solutions easier by taking away the complex coding logic and infrastructure and replacing it with simple queries. So there are 3 simple concepts that will help you understand how Drasi works. Drasi, you have sources, continuous queries, and reactions. Okay, so Drasi sources connect to the data sources. So some data sources that you may have, for example, Kubernetes, many different data sources we have there on the left, Dapper, MySQL, many others. So you configure these data sources as YAML files on a Kubernetes cluster to connect to things like Postgres, for example, and any data sources you're interested to observing. You get configure credentials as well to make sure you have access. And then at the heart is the continuous queries, where you bring those data sources together into one table view that constantly polls those back-end sources and makes sure that the information there is not only a single view, but it contains updated information. And then from there, you actually configure reactions downstream. And those reactions integrate with downstream platforms and services where you can actually trigger downstream actions to perform either a workflow or trigger an alert. So it's that piece in the middle where you take those data sources, create a consistent view that's constantly updated that can then be used to trigger these reactions. So I'm going to go take a look at a Drasi demo right now, which illustrates the power here. So in this demo, we're going to detect and react to risky container images that may contain malicious images. There's a common malicious code. So this is a common use case here. We'll demo how simple it is to implement a solution here with Drasi. So we have the architecture up on the screen. We have a Postgres SQL database and a Kubernetes source. So we're actually going to say publish an updated list of malicious containers to the database, join that query with the what's running on the cluster via Kubernetes. We're going to create a continuous query and then have a signal R reaction that drives a Grafana dashboard downstream. So I'm going to pass it to 𝗦𝗽𝗲𝗍𝗀𝗃, who's going to give us a demo here on how Drasi works.
Let's take a look at the solution using VS Code. A Postgres SQL table named risky image has been preloaded with data about a high-risk image, 𝗦𝗽𝗲𝗀𝗀𝗏0.1. Here are the pods running in the cluster and their images. Now let's look at the Drasi workspace. You can use the Drasi VS Code Extensions Explorer to manage your Drasi instance. Here you can see the Drasi sources, continuous query, and reaction in the workspace. Let's take a closer look at these YAML files. The source file points to the data sources you want to observe and the credentials to access them. The DevOps source connects to the Postgres database, and the K8 source points to the Kubernetes cluster. Now let's look at the continuous query. The continuous query, named risky containers and written in OpenCipher, connects image data from the Postgres source and pod image information from the cluster. Here's the information we will return in the query result set. The signal R reaction subscribes to the risky containers continuous query and gets change notifications when the query result set changes. Something to note is that the Drasi Explorer offers the ability to apply resources to your Drasi instance. For continuous queries, you can also debug before deployment. You can also attach the query after deployment to monitor changes in real time. Here is the current result set of the query. It lists pod 𝗦𝗽𝗏1 as running image 𝗦𝗽𝗏0.1. Let's insert a row to the risky image table that marks 𝗦𝗽𝗏0.2 as having a critical bug. As you can see, the result set immediately updates with this information and shows that pod 𝗦𝗽𝗏2 is running with the newly identified high-risk image. Let's look at a Grafana dashboard that is displaying the information about the pods and the images. I've used the Drasi Grafana plugin with the signal R reaction to build this dashboard. You can see the 2 pods running with the high-risk images in the dashboard. I'm going to delete the record for the high-risk image 𝗦𝗽𝗏0.2 from the database. As soon as that transaction completes, the dashboard updates as no pod running that risky image is detected. I'll add 𝗦𝗽𝗏0.2 as a risky image again so that 𝗦𝗽𝗏 shows on the dashboard. If you recall, the query combines data from 2 different data sources. Let's see what happens when I update the image on one of the containers so that the pod is no longer running a high-risk image. In the time that it takes to tear down the pod and bring it back up with the new image, the dashboard will update. And here you can see, after a few seconds, my app 2 disappears from the dashboard. This shows that the change data from the cluster updates the query result set as well.
Excellent. So if you want to get started with Drasi and learn about how you can drive change-driven infrastructure here on top of Kubernetes, there's a how-to guide, installation guide, and as I mentioned, that's all open source, so you can run it on any Kubernetes cluster or actually local on your machine using Docker as well. Okay, so that's a wrap. We're just in time here. We introduced 3 different projects, Headlamp, Inspektor Gadget, and Drasi, and you can see how using them in combination together to power generative AI troubleshooting, monitoring, and application introspection is a powerful platform. And as I mentioned, they're all open source. You can pick them up and start playing with them today. There are communities attached to them. And if you'd love to ask more questions, I'll be around after this session. I'll be hanging around outside, but I really appreciate it. If you have any feedback or want to see more about open source projects that we work on, here is our survey. I encourage you, good, bad, or otherwise, please give feedback. We take it seriously. And if you're interested in more sessions like this, we'd love to hear the feedback. Thank you very much. Have a wonderful evening, and thank you.